A closed right circular cylinder has a base radius of r centimeters and a height of 5r centimeters. If r is increasing at 2 over pi millimeters per second, find expressions in terms of r for the rate of change of the volume of the cylinder and the rate of change in the total external surface area of the cylinder. The fact it's closed means that it's closed at both ends, so both ends are a circle. Now, since this is in millimeters, I'm going to do these in millimeters as well. So r centimeters would be 10r millimeters, and 5r will be 50r in millimeters. So let's draw a quick diagram of our cylinder, and it doesn't have to be fantastically neat, as you can see. And so this is 10r and this is 50r. And so if we're looking at part A, we can see that the volume, well, we know it's the area of the end times the height, so it's going to be pi times 10r squared times 50r, which is pi times 100 r squared times 50r, which is going to be 5,000 pi r cubed. Now, we know that dr dt is 2 over pi. That was the increase of the radius. We want to find here dv dt. So that would be dv dr times dr dt. Now, dv dr means differentiating this, so that's going to be 15,000 pi r squared, and then we're timesing that by 2 over pi. So the pi's are going to cancel, and we'll get 30,000 r squared. And that would be in cubic millimeters per second. That's 30 r squared centimeters cubed per second. We just divide by 10 cubed. But either answer is probably okay. Now for part B, the total surface area is going to be pi times 10r squared for a circle on the bottom, and we have one of those on the top as well. And then we know that it's 2 pi rh for the curved surface. Of course, here the radius is 10r and the height is 50r. So that's going to be 10 times 50 is 500, times 2 is 1,000 pi r squared. So we get the surface area is 1,000 pi r squared, which means ds dr is going to be 2,000 pi r. So ds dt is going to be ds dr dr dt, which is our 2,000 pi r, times 2 over pi. Pi's are going to cancel, and then that's 4,000 r square millimeters per second.